Alright, so I have a fun little problem here about some father and sons getting together to trade baseball cards. So let's just dig into this to start digesting what's going on here. We have Chris and his son were among a father and son pairs who gathered to trade baseball cards. Well, first of all, this phrase, for father and son pairs. Well, that tells us that there were a total of 8 people. Now, I think it's helpful when we're talking about scenarios like this if we give our 8 people names. So I named the fathers Al, Bob, Chris, and David. I named the sons Howard, Gabe, Frank, and Ed. I think those are great names. So those are our father-son duos, and let's keep reading to see what we need to figure out about them. As each person arrived, he shook hands with anyone he had not known previously. I think that's kind of an awkward little tradition for their baseball swapping party. Why wouldn't you shake the hands of the people you knew as well? I don't know. Seems kind of weird to me, but that's their tradition, so we'll let them go with it. Each person ended up making a different number of new acquaintances from 0 to 6. Now, the first time I read that 0 to 6, I tried to do math with it, and it didn't make sense to me. But what's that saying is that we have 7 options. So 0, someone met 0, someone met 1, someone met 2, someone met 3, someone met 4, someone met 5, someone met 6 different people. Except for Chris and his son, who met the same number of people. Now, the 0 to 6, they can't really meet more than 6 people. Alright, so but that has an assumption with it. One of the assumptions is everybody knows their father or son. Okay, so the way I have this lined up, I'm assuming that Al and Howard are father and son, Bob and Gabe are father and son, Chris and Frank are father and son, and David and Ed are father and son. So we're assuming that every father knows their son and every son knows their father. So that leaves you with only 7 possible people to meet, but we're also assuming that everyone knows themselves. Otherwise, this would be a more philosophical discussion instead of a math discussion. So if everyone knows themselves, that leaves you with only 6 people that they could meet at the party. That's not their father and not themselves. Alright, before we dig into this, I want to have 2 charts. I want to have a chart that demonstrates that they already knew each other before the party, and a chart that shows that they met at the party. So if I connect Al and Howard over here, that means they knew each other before the party. If I connect Howard and Chris over here, that means they met at the party. Let's start with 0. Now, this 0 means that this person met 0 people at the party, and I'm going to say that that person was Al. Now, I'm doing that arbitrarily because all of these are just the same. I'm just choosing one that had to be the guy who met everybody. I mean, who already knew everybody, and that would be Al. To say that he didn't meet anybody at the party means that he already knew everybody going into the party. So I'll just draw all these lines to say he already knew all these guys going into it. And he doesn't get any lines on the other chart because he didn't meet anybody at the party. Now I'm going to switch over and look at the 6. Okay? And my conjecture is that Howard is the guy that met 6 people at the party, and it can't be anyone else. Now, if he met 6 people at the party, what that means is that he already knew 2 people, right? Because there's a total of 8 people. So if he met 6 people at the party, he already knew 2 people, but he already knows himself and he already knows his dad. So that means he met everybody that wasn't himself or his dad. So he met Bob, he met Chris, he met David, he met Gabe, he met Frank, and he met Ed. Alright, so that works. So there are 6 other people for him to meet. That works out that he could be the guy with 6. But now I want to make the argument that it can be no one else. I'm going to write in purple to make this argument. So let's look and say, okay, what? I think it could be Gabe. Alright, and to make this argument for Gabe would be the same argument for Frank or Ed or Dave or Chris or Bob, because they're all the same. They all know Al, and that there's nothing that distinguishes them at this point as far as relationships go. Alright, so if I can show you that it can't be Gabe, then that means it also can't be any of the other 5. Now, this is saying that Gabe had to meet 6 people at the party. Well, I'm going to get rid of all of Howard's lines to show you how that can't possibly be. Alright, to say he met 6 people at the party means he would have had to meet Frank, that's okay. He would have had to meet Ed, that's okay. David, that's okay. And that's Chris, that's okay. Okay? Now, we already know that he could not meet Al at the party because Al knew everybody going into the party. We already established that when we gave Al the 0. So he can't meet Al, okay? We also already know that he can't meet Bob at the party because Bob's his dad. So he can't meet Bob. He could meet Howard, okay? So that gives us a total of 5 lines. We can't get up to 6. And the reason why we can't get up to 6 is because Bob's not allowed and Al's not allowed. So that takes out 2 options. We only have 5 left. Okay, so he can't get up to 6. The reason why it works with Howard is because Howard can meet Gabe, Frank, Ed, David, Chris, and Bob. He can meet all those 6. The only one he can't meet is Al. The reason why that's working is because Al's the guy that knew everybody and he's his dad. So that cancellation doesn't happen out twice. It only happens out once because he's his dad. The guy that knows it all, knows everybody, is his dad. Now what we're going to see as we go through this is that the 1 and the 5 have to be paired together similarly, and the 2 and the 4 have to be paired together similarly as father-son duos, which leaves us with a 3 can be paired together with itself, and that forces Chris and Frank to be the ones that get the 3. And so because they're the ones that are allowed to have the same number of people. Alright, so I will go through this logic again with the 1 and 5 to show you why they have to be paired together with father and son. The exact same argument works for the 2 and 4. And we've seen it work with the 0 and 6. So I've cleared out all my lines. At this point, everybody is the same except for Al and Howard. We have Al and Howard locked in. Alright, I want to jump in with the 1, and I'm going to say that Bob is the guy who met 1 person at the party. So if he met 1 person at the party, that means he already knew 7. But that includes himself, which brings us down to 6. Okay? So if he already knew 6 people, that includes his dad. So I'll go ahead and draw a line, or in this case his son, because he's a father. So that's one of them. And we also already know that he knew Al. So that brings us down to 4 people that he knew going into the party. Now we have 5 options. We have Howard, Chris, Frank, Ed, and David. But he can't go up and know Howard because we've already locked in Howard's numbers. Howard doesn't know anybody going into the party except for his dad. So that means if Bob is the guy who met 1 person at the party, he already knew Chris, David, Ed, and Frank. And the 1 person he met at the party was Howard, which has to be the case because Howard met everybody at the party except for his dad. Okay? So if we give the 1 to Bob, it has to map out that way. It's a similar argument if we gave the 1 to any of these other guys. Okay? Now, we can't really give it to Chris, and I'll explain that in a second, or Frank, and I'll explain that in a second. So really, Bob, Gabe, Dave, and Ed, any of it could have been then, and that's going to force the rest of the stuff. So what I want to do is now pair that with the 5 to show you that if Bob is the guy who only met 1 person, then his son has to be the guy who met 5 people. Okay? So if Gabe is the guy who met 5 people, and there's a total of 8 people, that means that there were 3 people he knew going into the party. One of those is himself. That brings us down to 2. One of them is his dad, which we already have the line there, so we already know he knows that, but that brings us down to 1. And then the other one that he already knew going in the party is Al. We've already established that, so that brings it down to 0. Okay? So it works that Gabe knows that all those numbers work for Gabe. Now let's go over to the other side here. I'm going to erase Bob's numbers, Bob's lines. I think it's less confusing if we only have lines for one person. Okay, so Gabe knew 3 people going to the party. One of them was himself, and the other 2 were Bob and Al, which we've already established. Okay, but as far as who that leaves Bob meeting at the party, there's 5 people. Now, he has to meet Howard. We've already established that. And then that only leaves 4 other people he's meeting all these guys at the party. He knows Bob and Al going into it. He meets Howard, Chris, Frank, Dave, and Ed at the party. Okay, so it works for Gabe, but let me show you why it won't work for anyone else. So again, I'll use purple to show what I'm going to show doesn't work. Okay, so let's say hypothetically Frank is the guy that met 5 people at the party. Okay, so if he met 5 people at the party, that means he knew 3 people going in. Well, he had to know his dad. We've already established that he knows Al. We've also already locked in that Bob knew him going into the party. Because the only person Bob met at the party is Howard, because Howard met everybody. So Frank knew Bob going into the party. So if I go over here on the other side of the fence, what that means is Bob met Howard going into the party. Frank met Howard, Frank met David, Frank met Ed, and Frank met Gabe. And that gives us 4 total people. But our conjecture is that he met 5 people going into the party. There's not 5 people left for him to meet, because he knew his dad, he knew Bob, because the only person Bob didn't know was Howard, and he knew Al, because Al knew everybody. So that doesn't give us 5 people for him to have known. So it has to be Gabe that met the 5 people at the party. And the reason why is because we need the doubling up of him knowing his father and knowing the guy who knew everybody but one person. Without that doubling up, the numbers just will not lock in. And so we have that Gabe met Al and Bob, or knew Al and Bob going into the party, and met Howard, Chris, Frank, David, and Ed. So a similar argument is going to give us that the other partnership here, the 4 and the 2, have to go to a father and son duo. We cannot give them to Frank and Chris, because Frank and Chris need to know the same number of people. So we have to give those to Ed and David, his dad. And it could be in any order, but it has to go to a father-son duo. Those numbers do. And so then that leaves Chris and Frank for the middle numbers that are allowed to repeat at that point. I'll leave it to you to kind of persist out all the pairings to see how it has to lock in that way, but they're always going to work in pairs. You can working from the outsides to the insides, as far as the father and the son have to know the opposite number of people, or have to meet the opposite number of people at the party. I hope this gives you a sense of how to break the problem down. All these problems in this material can be a unique adventure, and you just have to wrestle with it until you can figure out what's going on with it and what the pattern is that's going to help you determine the solution you're wanting. Let me know if you have any questions as you continue to work on these.